Welcome to this presentation on the impact of excessive moisture, primarily in the form of flooding, on turf grasses. Excessive moisture in the root zone and its impact on root respiration was previously discussed in the photosynthetic module. Here we will look at major events that cause the turf to be covered or submerged in water known as flooding. Excessive precipitation in the form of storms or from over-irrigating can result in flooding. We will focus on the natural events or storms on the impact of flooding on turf and not much, if any, on overwatering. This photograph was taken in Sao Paulo, Brazil. Excessive rain has caused flooding of streets and roadways. Intensive forms of storms like hurricanes can bring large amounts of precipitation that can cause flooding. Hurricanes are primarily an issue along the Gulf Coast and eastern shore of the United States. The photograph in the previous slide was an aerial shot of Hurricane Katrina in 2005. Here you can see Hurricane Katrina just starting to make landfall along the shoreline of Destin, Florida. The amount of rainfall that can occur from a hurricane in a short period of time depends on how fast the hurricane is moving. Rainfall totals measured in feet is not uncommon. Besides rainfall and storm surges that can occur, the winds associated with hurricanes can be quite damaging. This is a Florida golf course after Hurricane Frances in 2004 passed through. Hurricanes can cause erosion. This is Destin, Florida beach showing erosion damage after Hurricane Katrina. Heavy precipitation itself can cause streams, rivers, or ponds to overflow their banks, flooding large areas. In this case, excessive precipitation has resulted in the stream that runs through this golf course to overflow and flood this golf hole. Golf courses are not the only places that can flood. This is a sports field complex, or this stadium. Flooding of this golf course occurred along a river. Probably not a good idea to build a sports facility or a golf course in a floodplain or a low-lying area prone to flooding. I've seen in some instances where a golf course like this has remained flooded that they had to take the greens mowers out in boats just to mow the greens. You never know what might show up on your golf course if it floods, especially near a river or a lake. Flooding injury to turf grasses consists of three major components: erosion, deposition of soil and debris to the extent that it kills the turf, and from direct submersion of the turf grass. Erosion is the loss of turf or soil due to the relative rapid velocity of the water. In this case, the river current associated with flooding undercut and eroded the soil underneath this green. This course is located north of Columbus, was damaged in mid-spring. This is just another picture of the flooding damage that occurred at the same golf course. This golf course is located in West Virginia. In this case, erosion was caused by a river flooding onto the golf course and destroying the green and bunker. On a local or smaller scale, stream or lake erosion along the banks are often fortified with walls or dikes, like the railroad ties used to fortify the 17th hole at TPC Sawgrass here in Jacksonville, Florida. A similar type of fortification of using a stone wall is used here. Larger projects or steep banks may require loose rock along the embankments. The use of large rock is referred to as a rip tap in erosion control. A rip tap type of fortification is shown here along the turf bank. A version of the rip tap method is using gabion baskets that hold stones for reinforcing the bank from erosion, then sodding over the baskets. For example, here is a stream that is not reinforced and the banks have eroded down into the stream. Or here, this stream eroding the bank. This stream was dredged and the banks reinforced with the gabion baskets and sodded over. You can see the effect. The problem with this reinforcement is if the water gets behind the baskets, erosion can occur. In the future, coastal golf courses, just like communities and cities along the coastal areas, are going to face erosion issues from storms and rising seawater. This picture is the 18th hole at Wild Dunes on the Isle of the Palms around Charleston, South Carolina. This picture was taken after a major beach nourishment and restoration project that cost millions of dollars to reclaim the beaches in the area. Shifting currents of the coastal area had eroded and destroyed this hole up to the condominium building. The hole was literally from where I am standing when I took this picture to the condominium building was washed out into the ocean in 2007. Using the condominium building as a reference, the next couple of pictures are taken prior to the restoration project. Here, beach and dune erosion. Ocean water lapping into the condominium building. Huge sandbags were used in an attempt to protect the building. This is the 18th hole restored by dredging and piping sand from the ocean back into place. This is an ongoing process. It seems every few years restoration or nourishment is required. Returning to flooding injury, the deposition of soil, salt, or debris may be damaging to the turf. If deposition is greater than 2 inches, the impact can be significant and if possibly needs to be removed. This picture is a golf hole located along the Ohio River that was flooded. Notice the significant deposition of soil and debris. Normally the severity of soil and debris deposit is greatest with slow-moving water. The amount of soil deposit can be significant. Although not occurring on the turf, this photograph was taken when the pond flooded and the water stagnated in the bunker. Note the soil materials that were deposited by the flooding prior to the water being removed. It's mud. Injury from water submersion is due to a number of different factors, many similar to those when root zones become waterlogged or saturated. Flooding injury from direct submersion is dependent on the depth of flooding, type of flooding, physiological condition of the plant, and water temperature. Turfgrass plants survive longer when the leaves are not completely submerged. Here the green patches located in the stream are creeping bentgrass. Turfgrass death occurs more readily if submerged under stagnant water compared to moving water. Shallow, stagnant water tends to be much warmer than moving water. Associated with stagnant water is the presence of algae and anaerobic organisms that deplete the oxygen in the water. These conditions hinder turfgrass growth and recovery from flooding. The physiological state of the turfgrass plant is important at time of flooding. Dormant turfgrasses are more tolerant to flooding than actively growing turf. Repeated flooding will reduce the tolerance of turf grasses, increasing the severity of injury. The temperature of water influences the submersion tolerance of turf grasses. In a study a number of years ago, James Beard looked at the water temperature and its impact on the flooding tolerance of 4 cool season turf grasses. Holding the water temperature at 20 degrees centigrade or approximately 68 degrees Fahrenheit, most of the turf grasses, especially creeping bentgrass, could survive for over 10 days underwater, and then the survival rate dropped beyond 20 days. When he changed the water temperature to 30 degrees centigrade or 86 degrees Fahrenheit, survival was problematic. Creeping bentgrass could reach 50% survival at 10 days, but the remaining turf grasses were killed within 1 to 2 days. This photograph was taken in the Cleveland area during a hot, wet August, depicting what water temperature and stagnant water can do. In this case, excessive precipitation caused the stream to overflow, resulting in flooding into the lower lying areas of this fairway. The turfgrass species was Poaño, and given the temperature of the water, and no doubt the turf was under stress from a long hot summer, death occurred within a day or two. Warm season turf grasses are more tolerant of flooding than cool season turf grasses. Bermuda grass, for example, can survive over 55 days of submersion. This photograph is from Pacific Harbour Golf Course in Australia that experienced severe flooding, but fortunately the turf is Bermuda grass and survived the lengthy submersion. This table summarizes the relative tolerance of a few turf grasses to water submersion. Generally, warm season turf grasses are more tolerant than cool season turf grasses. In case of flooding, what can you do? Well, you can remove the water as soon as possible. Normally, though, you need to wait for the water to recede. Sometimes sump pumps are used to try to speed up the removal of water. As the water recedes, remove as much sediment as possible, especially if putting greens have been flooded. Once the sediment dries and settles on the turf, the surface is often sealed, making turf growth difficult. What a mess. What they are trying to do is wash the sediment back into the river and shovel some of it off. Success rate is not going to be very good in this case. Some sort of deep cultivation should follow to help penetrate and disrupt any surface sealing caused by sediment and algae. Once possible, coring and removing the cores is a common cultivation practice on turf that has suffered flooding. This is a golf hole that was flooded from the stream overflowing. In this case, as much of the debris and contaminants were removed, but the flooding occurred during a hot period in August, resulting in the death of the turf. The hole was reseeded to perennial ryegrass and a few months later was open to play. This concludes this presentation on flooding.